Hello, my name is Sayantika Adhikari and I will be serving as an audio navigator for material science. Before we start our session, let me introduce myself. I have completed my bachelor's from chemical technology and master's from plastic engineering from Central Institute of Plastic Engineering and Technology, Lucknow. Now I shall give you a vivid description on what is GATE. It is a graduate aptitude test in engineering. Through this entrance exam, engineers are selected in various public sector units and for master's program and also PhD in IITs and NITs or any other government or private universities. If you are interested in public sector unit, let me mention only one PSU, that is Indian Oil Corporation Limited, conducts recruitment through engineering science, code XE. Here it is mandatory to choose polymer science and engineering as one of the subject, and the other subject may be of your choice mentioned under the engineering science like fluid mechanics, material science, solid mechanics, thermodynamics and food technology. If you are interested in further studies, you can select any two subjects I have mentioned and appear for GATE through XE. In both the cases, general aptitude and engineering mathematics are compulsory. Now this was a basic idea of GATE for those appearing through engineering science. Next, in this audio, I will give you a brief idea on how to prepare for your GATE on the subject material science. This subject alone will carry 35 marks. The syllabus is divided into 8 sections. Section 1, Processing of Materials. Section 2, Characterization Techniques. Section 3, Structure and Imperfections. Section 4, Thermodynamics and Kinetics. Section 5, Properties of Materials. Section 6, Material Types. Section 7, Environmental Degradation. And Section 8, Elements of Quantum Mechanics and Mathematics. Now while you are preparing, it is wise if you start with Section 3, Structure and Imperfections, and complete all the subtopics mentioned under this. By doing this, you will get the basic concept of material science and it will help you further for preparing other sections in the subject. The subtopics are as follows: crystal symmetry, point groups, space groups, indices of planes, close packing in solids, bonding in materials, coordination and radius ratio concepts, point defects, dislocations, grain boundaries, surface energy and equilibrium shapes of crystal. There are multiple choice questions and numerical answer questions carrying 1 or 2 marks. Generally, questions carrying 1 mark are common from crystal symmetry, point and space groups, indices of planes, point defects, dislocations, grain boundaries and equilibrium shapes of crystal. They may be a multiple choice or numerical answer type. And 2 mark questions are preferably from crystal symmetry, close packing in solids, indices of planes, bonding in materials, coordination and radius ratio concepts, point defects, dislocations and surface energy. You should be very thorough with geometry of various crystal structures like simple cubic, face-centered cubic, body-centered cubic, hexagonal closed packing and diamond crystal. The coordination number and atomic packing factor of various structures are very important. In 2015, there was a question on density of a metal crystal structure. It was a numerical answer type question carrying 2 marks. So, density computation of metal and ceramic structure is important. In 2003, There was a question asked to find the volume of the unit cell of a metal with hexagonal closed packing for a given lattice constant, carrying 2 marks. So if you are very clear with crystal geometry, it will be easy for you to score marks. Study the lattice parameter relationships and figures showing unit cell geometries for 7 crystal structures, as questions on Bravais lattice and rotational symmetry are common in GATE. There are questions on crystallographic direction and planes, which carries 2 marks. So you should know how to determine an angle between two planes. Determine the planes of a crystal structure from a given Miller indices. Every year there are questions carrying 2 marks on this particular topic. Thus it is mandatory you cover this topic, and it is also very easy. Be thorough with the extension rules for different cubic crystal, which comes under Bragg's law of X-ray diffraction. This will also help you for preparation on other topics. Next, for bonding in materials, you have to first understand the atomic structure. Topics that come under atomic structure are the quantum states, periodic table, ionization potential, electron affinity, and electron negativity. After completing this, you can proceed to chemical bonding and must learn to find bond energy, bond type, and bond length, and study the various types of chemical bonding like ionic bonding, covalent bonding, metallic bonding, and secondary bonding. They generally ask multiple choice questions of 1 or 2 marks. You should be clear with the theoretical part, as the questions are confusing. Only if you have a clear view of the topic, you can answer correctly. Next, you should study the structure of solids like covalent solids, metals and alloys, ionic solids, structure of silica and silicates. As I have already mentioned earlier, learn to determine the packing efficiency, that is atomic packing factor, shortly known as APF, and also the coordination number of various crystal structures. This will help you to deal with the numericals related to the structure of solids. In covalent solid, the crystal structure of diamond, graphite, carbon and fullerenes are very important. They ask multiple choice questions carrying 1 mark on this topic. Then, in metals and alloys, the geometry of close packing of equal size sphere are studied, that is, various types of stacking formed in various crystal structures. In ionic solids, the ratio of the cation to anion radius for a particular configuration, the ligancy and structure of some ionic crystals like sodium chloride, calcium chloride, magnesium oxide, zinc blend are important. Be very thorough with the structure of silica and silicate ceramic. In 2017, there was a numerical answer type question to calculate the cation to anion radius ratio for a given crystal structure carrying 2 marks. If you study structure of solids properly, you will be able to solve this question. There are also multiple choice questions on the interstitial voids in closed packed structure, namely tetrahedral and octahedral voids. Now next comes the crystal imperfections, of which only 3, the point, line and surface imperfections are mentioned in the syllabus. Point imperfection, known as point defect, line imperfection known as dislocations, and topics like surface energy and grain boundary comes under surface imperfection. A point imperfection, also referred to as zero-dimensional imperfection, are imperfect points like regions in the crystal. In GATE, there are questions on vacancy, substitution impurity, or interstitial impurity of a crystal. Most of the time, they ask questions on Frankel and Schottky defect. These two defects are very important. Try to understand these defects properly. Clear all your doubts. Generally, multiple choice questions are asked of 1 or 2 marks. Then comes the dislocation. These are one-dimensional imperfections in geometrical sense. Dislocations are best understood by referring to two limiting straight line types, edge dislocation and screw dislocation. Study these two types of dislocation elaborately. A plane called slip plane is a very important dislocation terminology. Then a vector called Burger's vector, which defines the magnitude and direction of the displacement, characterizes a dislocation line. Multiple choice questions are common every year from dislocations, and the questions always confuse the student. The questions are on slip systems, mentioning cross slips of two different dislocations. Study properly, clear your doubts, keep a clear view, or else you might end up losing marks. Next is surface imperfection, where topics like surface energy and grain boundaries are covered. Surface imperfections are two-dimensional in mathematical sense. Numerical answer type questions like to calculate the surface energy of a metal is generally asked from this topic. There are multiple choice questions from the boundary region called crystal boundary or grain boundary. So be thorough with the atomic arrangement at grain boundaries. Till 2017, there has been no linked or common data questions from this section, structure and imperfections. You can allot 5 to 7 days to complete this section depending on how many hours you can study. Don't extend it further as you have other sections to complete. After section 3, start with section 4, Thermodynamics and Kinetics. Because this is very easy and numerical answer question is very common from here. There are also linked or common data questions. Questions from this section mostly carry 2 marks. The subtopics are as follows: phase rule, phase diagrams, solid solutions, invariant reactions, lever rule, basic heat treatment of metals, solidification and phase transformation, Fick's law of diffusion, mechanism of diffusion, and temperature dependency of diffusivity. The phase rule enunciated by Gibbs has a simple form through which we find number of degrees of freedom or number of components or number of phases for given values. This is also called Gibbs phase rule. In GATE, there was a question on maximum number of phases that can be in equilibrium in a system, which carried 1 mark. Again, a 1 mark question on phase rule to determine the degree of freedom for a binary phase diagram was asked on GATE. Next is phase diagram, which are classified based on number of components in the system. There are urinary diagrams, binary diagrams, ternary diagrams, and so on. Study how to interpret these phase diagrams like magnesia alumina phase diagram, iron iron carbide system, the lead tin phase diagram, which specially binary phase diagrams. Study the microstructural and property changes of in iron carbon alloy of iron carbide phase diagram like pearlite, bainite, martensite, spherodite, etc. See, you cannot predict exactly what they would ask, so it is good if you complete the entire topic in a broad way, forming a clear view. Next is solid solution. Even after transformation to a solid crystalline state, the metals retain their homogeneity and consequently their solubility. A solid solution is said to have formed. Solid solution occur in either two distinct types: substitutional solid solution and interstitial solid solution. A 1 or 2 mark multiple choice question may be asked from this topic. Next is invariant reaction, which is very easy and also important. You should learn the 4 most common invariant reaction, that is eutectic, eutectoid, peritectic and peritectoid. Be thorough with the phase boundaries at the invariant line and go through the details of the reaction. Multiple choice questions carrying 2 marks were previously asked in GATE. Next comes the lever rule. Based on this rule, every year there will be a linked or common data question. Numerical answer question carrying 2 marks each. So study properly. Practice with various phase diagrams how to determine weight fractions of liquid or solid. The questions are generally not tough. So by covering this particular subtopic, you can score 2 to 4 marks. Next is heat treatment process, which involves a combination of operations for heating and cooling of a metal in a solid state to obtain desirable products. You must study the classification of the heat transfer process like annealing, normalizing, quenching, tempering, Marr tempering, Aus tempering and Marr aging. Generally, a multiple choice question of 2 marks is possible from here. It may be match the following type involving 2 subtopics. In 2016, there was a 2 mark multiple choice question asking to match the heat treatment process of steel with the microstructural features given. If you know the heat treatment process and be familiar with the microstructural changes of a iron carbon alloy, you can easily solve this question. Then there is solidification and phase transformation of metals. Solidification occurs by nucleation of very small crystals which grow under the thermal and crystallographic conditions existing under solidification. Nucleation is the beginning of phase transformation followed by growth. There are typical applications of the principle of nucleation and growth like transformation in steel, precipitation process, solidification and crystallization, glass transition temperature, recovery and recrystallization and grain growth. There are generally multiple choice questions from here. Be thorough with the theory part. Numericals are not needed. Next is Fick's law of diffusion, followed by mechanism of diffusion and temperature dependency of diffusivity. Diffusion can be defined as the mass flow process by which atoms change their position relative to their neighbors in a given phase under the influence of thermal energy and a gradient. Fick's first law, used to describe flow under steady state condition, must be studied. Fick's second law, an extension of the first law to non-steady state flow, must be studied. By learning the laws of diffusion and diffusion coefficient, you can solve the numericals in this topic. Every year there is a numerical answer question carrying 2 marks based on the Fick's law of diffusion. The mechanism of diffusion is either interstitial or substitutional. The theory part should be properly studied. Try to understand the vacancy mechanism, atom interchange mechanism. There may be a multiple choice question based on the theory of this part. From temperature dependency of diffusivity, we can understand the diffusion coefficient related to absolute temperature by Arrhenius type equation. They may ask numerical type questions from here. Try to prepare a note on each subtopic so that during revision practice as many numerical you can. Allot a time period of 5 to 7 days for this section. Questions on lever rule of a phase diagram is very common. So with this section you can score 2 to 4 marks easily. Try not to skip any subtopics because every year they ask something related to the syllabus but which were never asked in previous year. With this we complete our section 3 structure and imperfections and section 4 thermodynamics and kinetics. Hope you liked my audio. Wish you good luck.